Hello, welcome back to Rich Tech. Today we'll deviate a bit from our normal MacBook chargers and have a go at this HP charger. This is of the small or blue pin category, and its output is 19.5 by 3.33 amps. I've tested it, connected it to a power source. It's the input, and I've tested it with a computer. It's not working, but it's always safe to test with a fan, as I'm doing in this case. You put the negative wire outside and the positive wire, which is this rod, you put it inside here. And if this charger was okay, it would be running this fan. So if the fan is not running, the charger has a problem. I want to attempt to see what the problem is and repair it if at all possible. Thanks for your time once again. Keep watching. If you are new to this channel, I'd like to request you to subscribe if you can. Let's go ahead with the repair. To repair this, we need to open it up, and to open it, you just hit the ends firmly, and this case will pop open, as I've done in this case. Wow, it seems there's some water damage inside here, and we can go ahead and check inside if everything is okay. There's a lot of dirt inside it. Now the cables come and connect on the circuit at this point. As you can see here, this one, the white one, is the V out, voltage out. The black one is the return, and the blue one is the one known as ID, is the one which enables the charger to communicate with the charger, with the computer's circuit to enable the charging. So that's how it is. We don't know what the problem with this is. The capacitors look okay from that side, and from this side, let's see, the input looks okay. Now the first thing I'd like to do is to test for the continuity of these wires from here to the end here, and with that, for that we'll use a multimeter. This is the lower part of the circuit board. The black wire is connected to that, the blue wire is connected to the middle, and the white wire is connected to that. So let me go ahead and test this for continuity. I'll put this on the outside. This is connected, the outside portion of this, first of all we can test. The outside portion of this connector here, or this jack, is connected to this black wire. And you must confirm that it's not connected to any of these other two. Okay, then I'll connect this to the inner wall. Remember, there is a pin in the middle there, as you can see. That pin is connected to this blue wire. Then there is this inner wall of this jack is connected to the positive or the white wire. So let me test the inner wall first of all. So that's okay. And the middle pin, which is difficult to test, but we'll try to without touching any other part. So we have continuity on all these three wires. To find out any further problem, we'll have to open up this case and see what lies inside. Opening up this metal casing is fairly simple. Lift up these metal clips and we pull these apart. removing the outer cover. This is how the charger looks inside, and as you can see, deep down there near that resistor is a lot of corrosion. There's a lot of corrosion. It seems this charger spent some time underwater, or water came into contact with it. You can see also this side, there's some water damage. See that rust, and here too you can see it on this plastic cover. There is some water damage. The capacitors look to be okay, they're not swollen, same to these other two. The transformer here seems to have some corrosion on the resistor down here too. Otherwise everything else looks okay. I'll attempt to clean this up using my brush and see if this can work. Now, in the course of diagnosing this charger, I connected it to a power source and didn't hear the distinctive pop which shows that it has an input, so power is not getting into this HP charger. So on further diagnosis, I looked and realized that this fuse has one leg broken. Fuse is broken right here. You can see one leg is broken. So this fuse is not working. So I want to see if we can change that, and this problem can end, and we can have a working charger. In the meantime, I've got a working fuse here. Let's change the two and see what happens. So here is our old fuse. This is our new fuse. So let's connect this to a power source and see if it's working. The fuse that I've replaced is working. I've tested it with a multimeter. Now let's see what happens when you connect this to a power source. I've connected the adapter to a power source, and I've not switched it on. I want to switch it on, but I've had to place the cover over it just loosely like this, because some of these chargers tend to explode. So as to protect myself and to prevent any injury, I'll put the cover back on slightly like that, still open, so that we can go ahead with this test. Now I'll go ahead and put the power on. See what happens. Ready? The power is on and nothing has blown, so this is a good sign. Let's see if there is output at this end. And to test for output, I use a fan. The positive is the red. Place it on the inside here. And the negative is the black. Still doesn't power this fan. So there is no power still flowing through. Let's continue with our diagnosis. Now, as I continued the diagnosis on this charger, we replaced the fuse. No, the fuse is not the problem. For those who do not know the fuse is this box like black object. So the power comes in through here. You see right there on this side, then it comes out through here. The black cable goes into the circuit. Looking on sideways, now the power has come through this port, through the black cable onto the underside of this circuit board right there. and then it flows through this connection to that point. Now if you look at this point, it is our fuse. That's the fuse right there on one leg of its one of its legs. Then it will go through the fuse and come out. Can look at the other side again. That's one of the leg of the fuse, and then come out through the other leg of the fuse. Now the power, we can continue tracing the power coming to this side. What is underneath here? This power is this connection is going after the fuse. It's going to that point. Now all we did was to replace the fuse. Now if you want to know what the problem is with the charger, you trace the power. We've already traced. We found that this fuse was broken. Here it is. One leg of the fuse was broken, so there was no power going through it and coming out. So we replaced that, and now the fuse was okay. Then we traced the power to this point. This point is where we have the induction coil. The induction coil is this. I won't go much into physics, but power is induced when it passes through this coil, so I won't go dwell much on that. So in this induction coil we have two wires, one looped over the other, and these are their ends. Now this one was on the circuit right here. If you look at it carefully, one leg is broken, but it wasn't broken when it was on the circuit. So to test for the working or the perfection of this induction coil, I tested these two ends. We must have continuity because we have two wires looped on top of each other. You have to assume that it's definitely obvious that the two ends belong to one wire. It's like this cable right here. These two ends belong to this cable. So if you test with a multimeter, you must have continuity between these two. So any two legs of this induction coil must have continuity. If you test them with a multimeter, you will have that sound on your multimeter telling you that there is continuity. And so I tested this. I could not find. I found only continuity on one side of the legs and not on the other, telling me that there's a break in one of these wires, because there are two wires like this coiled around this ceramic or plastic part here. So I removed that and replaced it with another one, which you can see right here, and I soldered its legs right there. So the power comes from the fuse, comes out through the fuse, comes out here, and then comes to one leg of the induction coil, which is continuous with this. So these two have to have continuity and these two have to have continuity, and that's how you know if there is a induction. And I tested the two and there was no continuity, so I replaced that. After replacing that, I soldered, and now we want to test if there is any problem with this. Remember, we are following to see where we are following the power to see where we have a problem in this. One thing I have to insist on is that all these parts contain electricity. When you are testing, make sure you cover this part because you can get a nasty shock. So we want to put our power cable once again on this side and see what happens. Protect myself against the nasty shock which is on this board. I will just use this covering. Over the charger and also place it underneath. You can place the one underneath first of all. Here is our charger covered. Now we can't get a nasty shock, and if anything explodes, it won't get into our eyes or face. I'll connect it to our power cord here. There is already power flowing through this, and the reason why I'm doing this is I want to hear a pop. Every time you have a pop here, you know that you have an input. Input means power is going into the charger. So I have this on as opposed to plugging it and then turning the switch on. I won't hear the pop. I want to hear it when I put this connect it. Let's hear this. There is not much of a discernible pop, but let's test now and see if we have any output. This is the end. That's our fan. We want to test this blue pin and see if there is any output. Positive goes to the inside. And there we are. Our diagnosis and repair has been successful. This charger is now working. The problem was the fuse and the induction coil, which we've managed to trace, diagnose and replace. Now this fan is working perfectly. And that's how you diagnose and test and repair your HP charger. And the other thing I'll point out here is that this fan is a good test instrument, because you get to see how the fan is rotating. If this fan is rotating and it's jacking, stopping at one point or another, you know that the charger is failing. The components in here are failing. But if it has such a strong rotation, there is no stoppage, you know that your charger is perfect. We can also test for the voltage. Again, here is our charger, that's the cable. Here is the output on the blue pin. Let's test using our multimeter. I've already set the multimeter to the 200 volt. This charger is for, I think, 19 point something volts. So I'll test using our multimeter and see if we have the correct voltage after the repair. And there we go, 19.8 volts. Before I close the charger, I thought it would be best to test it on a HP notebook. Here I have a HP Elitebook 2540p, which is missing a screen, but otherwise everything else is good. So I'm going to test it on this. I've already soldered a big pin adapter there, so it can go into this. Let's close it up, because we want to check if this is being powered. And where we'll look at is this point. That point, we want to check those LED lights. Now let's connect the charger. Charger will be connected to, let's see, connect our charger right there. And as you can see, we have success. I can hear the Elitebook powering up. Wish we had the display, you could see it showing it charging. But that's it. That's a good charging right there. So the amber. And that's how you repair your HP charger. If you like such content, kindly consider subscribing, liking and sharing. Thank you for your time.